Hey everyone, welcome to yet another episode of Tech Talks with Tomer, in which we explore the world of blockchain by talking to the technical leaders who are building it. I'm your host, Tomer, and I'm VP Product at the Stellar Development Foundation. And today we're going to talk about smart contract developer tooling. And with me is Chad Ostrowski, aka Chad O, co-founder at Aha Labs, a software studio that focuses on smart contract tooling across multiple blockchains, including Stellar's very own Soroban. Hey, Chad, what's up?
Hi, Tomer. Yes, that's right. And for context, I used to be at Near Inc., which is now called Pagoda. So most of my experience is with those two platforms at this point. And I have some experience with CosmWasm as well, or some familiarity, I should say, with CosmWasm. So yeah, Near Inc. for about a year and a half. And then Willem and I don't know how much of this story you know, how much of it we want to get into here, but like we both parted ways with Near Inc. on the same day, and then started our own company, Aha Labs, after that. And mostly at first we were still working within the Near ecosystem, building stuff within the Near ecosystem. There were other people in that ecosystem who wanted our help with some things. And I gave a talk about some of what we were working on, RAEN. It was called Near, spelled backwards. I gave a talk about RAEN at NearCon last September. And Tyler, who you work with, Tyler Vander Hoven?
Yes, from our DevRel team.
Yeah, Tyler from DevRel. Tyler from DevRel was there, and he was in the audience during my talk, and he was basically like, hey, we would love to have you come build this kind of stuff over on Soroban. And we had a bunch of talks about Soroban where he convinced me that it was worth looking into. And so like we pitched your team some ideas, and here we are.
Yeah, and I think when Tyler came back, he showed us RAEN, or your demo of RAEN. And it basically felt like kind of like storming into an open door because we were definitely into these type of applications. So maybe for our audience who's not familiar with RAEN, you can tell us a bit what that is and what was your motivation to build this? What kind of problem were you trying to solve?
Sure. I'll start with the thing I've wanted since joining Autark in 2019, and really since exploring, I did like a little research project at a previous company that I worked at that was trying to build a decentralized app. And the thing that I have wanted since then is like the Ruby on Rails for the distributed web, right? I want someone to make some conventions around this stuff. Ruby on Rails, the whole idea was convention over configuration. So rather than needing to configure every single piece of your app yourself, you can have these conventions that are strongly opinionated. Maybe experts will disagree with those opinions, but they're going to set some conventions and say, like, here's a reasonable way to do things to get you started. Here's how you can do routing. Here's how you can build your front end. Here's how you configure your database, right? So what's the equivalent of all of that? What's kind of the like conventional architecture of a decentralized app, rather than needing to go discover all the pieces of it yourself? So at this point, there are like certain pieces that every decentralized app is going to need. It's going to need some smart contracts. It's going to need decentralized storage. It needs a front end, and that front end needs to be a pretty hefty front end, right? It's like a it's like a Jamstack front end, JavaScript APIs markup, right? So it's like a heavy static front end with a big chunk of JavaScript that does all of the calls to the blockchain and to decentralized storage. So we know we need all of those pieces, and we probably need indexing layers, something like the graph, which is its whole own can of worms. So how do we get people to the point where they can run one command in their command line and scaffold out all of the pieces that they're going to need? So that's kind of the vision, the thing that I have wanted, that it doesn't seem like anyone else has worked on from top to bottom. So that's kind of like what's in my head, the thing that I want. And one piece of that is that you want it to be as easy. The dream is that you want it to be as easy to build against someone else's smart contracts as it is to build against your own, right? Like in this world, rather than needing your own database and your own server, if someone else already built the piece of functionality that you want, you should just be able to plug into it and build a new front end that uses the same data, or that just uses a specific smart contract for one piece of the data and maybe has its own smart contracts for other stuff. So how do you make it as easy to build against someone else's smart contract as it is to build against your own? So that was kind of the challenge, especially in Near. Near at the time didn't even have something like ABIs. If you're familiar with Ethereum, the ABI is the thing that makes it easy to interact with a smart contract from your JavaScript. So you give it the ABI for the smart contract, and then you know what functions it has and what arguments those functions take. And so it makes it easy for the app developer to make calls to that smart contract. So we needed to like build an ABI system for Near, which it turns out we did at the same time as the Near team that we had parted ways with before. So there are like two competing versions of this for Near now. One of them is RAEN. And then we made a front end that consumed that ABI and built something. Again, if you're familiar with Ethereum, there's Etherscan, and there's that piece where you can make calls to a smart contract in Etherscan. We basically built that, but prettier. And since our version of ABIs pulls in all of the comments from the smart contract author, right? All of the comments above a specific function, it pulls all of those in so that when you're interacting with someone else's smart contract, you see all of that. You can see what this function is for. So it's basically like Etherscan, but prettier. The front end piece of it is it grabs the ABI. I should say, like, so there's the production side of it, right? Like if you use RAEN to build your smart contract, you say RAEN build, and you tell it the path to your smart contract. If you do cargo build, and this is only for Rust smart contracts, I should say, for now. Near, you can write smart contracts in Rust, JavaScript, or assembly script, though that's like less supported at this point. But so this is Rust only, so you could just build with cargo. If you build with cargo, you don't end up with the ABI in there. If you build with RAEN, you do. So it gets embedded right into the WebAssembly file, the .wasm file, which gets deployed on chain. And that means that like rather than having this external service, it's all built right in on chain. You get the ABI. And now that it's there on chain, other tooling can make use of it. So the first piece of tooling that we made to make use of that on-chain ABI is this front end that basically generates, it's like interactive documentation, right? It lets you interact with it, but it also tells you what all the functions are and gives you all of the documentation comments that the smart contract author wrote. I feel like I went a lot of places. What was your specific question?
No, I think to be honest, I don't remember what I asked, but I do think that it's that's super interesting because I do feel like in the world of computer science, like we keep like reinventing the same things, and that like this idea that even Alan Kay, who invented the concept of like object-oriented programming, used to talk a lot about the fact that objects should actually convey all the information that's required to communicate with them, right? So, this idea that smart contracts should actually include a specification for these are the things that I do and this is how you communicate with me. It's obviously not a new concept, but it is like a new concept in the world of, in some ecosystems, and we keep having to reinvent that. So I do find that super interesting. And yeah, I think when we saw RAEN, and obviously in Soroban, we can talk about this in a bit, we actually, from the get-go, implemented this specification. It's called Sorobon spec. And basically every smart contract has this like custom section that describes what the contract does and what its data looks like. But if we take a step back for a second, I am curious, you've been working on Near for a while, and then, Tyler got you interested in Sorobon. You went to Soroban land. You actually wrote a small piece as part of our Sorobonathon, which is this program that we have to award small awards to people who write content about Soroban. And I am curious, like, what were your first impressions about Soroban, and how did it feel after spending some time with Near, kind of like expanding your kind of like sphere of smart contract universe?
Yeah, I guess I'll start with one of the things that I loved was that Sorobon is putting the like ABI, if you will, the spec, the Sorobon spec, I feel like there could be lots of names for this thing, but the description of like the functions and the arguments for this smart contract, that they're all going to be on chain from day one. Like that was definitely part of what piqued my interest, just because the world of tooling that can be built around that is so much richer when you know that all of them are there and that you can pull any of these, that like every contract is typed, right? Like you can get all of its types on chain. Then the tooling you can build for that blockchain is so much more robust. So like, I think it was a great decision of the Sorobon team. Good job, y'all. One of the biggest differences writing smart contracts with Near and with Sorobon that anyone would notice right away is that in Near, you can use regular Rust, if you will. You can use the standard library. And in Sorobon, you cannot use the standard library. And the reason for this is that if you think about when a smart contract, when there's a call made to a smart contract, the runtime needs to fetch the bytes that represent that smart contract out of storage and load it up into working memory. And that has a cost, right? That takes some time. And the fewer bytes it needs to deserialize, the faster it can do things. So Sorobon's decision to use no STD, to only allow contracts to be written in this way that doesn't use the standard library, no STD mode. STD standing for standard. That makes it much more complex to write contracts for, much more, it's like it increases the cognitive burden for the author of the smart contract. Yeah, and it means that you can't use libraries that use standard library, right? So there's a whole bunch of Rust libraries that you can't use. So I guess I'm curious to hear your thoughts, Tomer, on like the pros and cons, why you decided to do that. My first impression though, so like you've got to write smart contracts in this very specific way. Sorobon SDK has this kind of straightforward approach to accessing the storage, the key value store for a smart contract. That was another thing that struck me. I wrote a whole post about that and did a little exploration of Near versus Sorobon versus CosmWasm. But aside from those two things, yeah, so like you get through those quickly enough, especially for like a hello world example or the basic examples. It's like, okay, I can understand, even though it's no STD, like I can read this code and understand what's happening. And then the contract that you actually create is like way, way, way smaller than Near. I'm used to Near smart contracts that are built with Rust being on the order of 100 kilobytes, 200 kilobytes, right? That's very normal. And I forget what it was in Sorobon, like way less than that. It was like 4 kilobytes or something. And there are some optimizations you can do with the Near version, but it still ends up coming in at like 70 kilobytes for like the normal way of doing things, unless you get really extreme and really like niche. So yeah, but there are, Near, kind of the philosophy in Near is that they don't need to care because it's not quite yet a fully sharded blockchain at the hardware level, but the idea is that it's dynamically re-sharded so that if there's too much traffic on one particular smart contract, it could get put into its own shard, run by its own validators, run on separate hardware. And so it doesn't really matter that smart contract might be like really hefty to run because it's sharded at the hardware level. Sorobon doesn't have that. Sorobon has this cool thing where it does this pre-flight and figures out like, okay, this call is going to use these smart contracts so it can run in its own thread on the same hardware, right? There's like the same server that has to run it. So those are kind of, there's like a whole bunch of questions I have in this area, but I would like to start with I'm sure, I think y'all went back and forth on like no STD versus like letting people use standard library. And I'm curious to hear what went into that decision and why you decided no STD was the right choice for Sorobon.
Yeah, so I think if you look at the Sorobon environment itself, that's just a WASM virtual machine, right? So that actually doesn't know anything about Rust or standard library or not. It doesn't care how you compiled your contract to WebAssembly, right? But we are, like you said, we put a lot of emphasis on performance and the kind of like, Stellar core in the environment. We're very conservative engineers, and we're trying, Stellar already works at scale, and some of these other blockchains, it's very easy to talk about how you do 6,000 transactions per second when you are actually doing like 4 transactions per second on your, in average. So it's very easy to talk about scale when you're not actually operating at scale. Sure. So, like Stellar operates at scale, and we're very conservative about the type of traffic that we have. So, obviously in the old days, we were very conservative to the point where we didn't really have smart contracts. Everything is just like baked into the low level protocol. Everything is super optimized. But, the move to smart contracts doesn't mean that like we throw cautious out the door or out the window. So the idea is, that Sorobon really tries to optimize wherever it can. And so we do strive for, we want the contracts themselves to be, as small as possible. So to not overload the validators with too much data. But we also want to make sure that the computation itself is not too expensive. So like you said, a lot of the things that in other platforms happen on the virtual machine side, we try to delegate as much as possible to the host itself, so that the virtual machine doesn't need to handle complex logic of doing things like like serialization and deserialization, which if you look at contracts in like the Near ecosystem or the CosmWasm ecosystem, they spend a lot of time serializing and deserializing information. Mm-hmm. So, out of this, trying to get contracts to be as small as efficient as possible, we have very strict limits. So now that the SDK actually needs to build them, the question is, how do you optimize on the SDK side to construct things that are pretty small? Now, Rust, which I know you love and I love too, and we have like a great Rust team in Stellar, wasn't really built with the idea of creating tiny executables. Rust was built as a systems programming language, not really for embedded systems, not really for building small stuff. So the question is, how do you kind of like force it to build small things? And so there are a bunch of things that you can do. And one of the things you can do is the no STD, which is a bit foreign to a lot of Rust developers because you're just used to it always being there. And like you said, a lot of libraries actually depend on it. We do find that a lot of libraries depend on specific aspects of it that we can actually kind of like retrofit without bringing the entire standard library. So for example, allocators are a big thing that you can actually create. There's some finagling involved, but you can actually get an allocator without having a full standard library. And we've been some folks have been experimenting with that on doing various small crypto functions on the smart contract side. So there are ways. I do think that it's kind of like a bit of a hump when you start developing for Sorobon, but as soon as you build a mental model of how do I use the things that I usually do in a standard library without a standard library, and the Sorobon SDK actually gives you most of this functionality. So it's available. It's just not necessarily intuitive in like the first second, but after a bit of experience, I think that it kind of like smoothens out. I do want to touch on Rust a bit more because I know that you're very bullish on Rust. I've heard you say great things about it. With that said, and putting Sorobon aside for a second, still a lot of people consider Rust to be this this barrier of entry into smart contracts. So is this something that will fix itself with time? Like how do we handle this issue?
So I think there's like two, right? There's like two opposing ideas out there, I guess, right? On the one hand, Rust is kind of hard to learn, especially like borrowing and ownership. It's this, it feels like you need to learn another language first, and then you can go learn Rust, right? Like, I think that's I'll say that at a minimum, where it's like, it's not what you would teach a newbie programmer. There are like too many gotchas, too many things to understand. You kind of have to understand the heap and the stack and like, what the computer is doing at a sort of fundamental level. And then there's just all the, like casting one type to another type. There's all these different types of string, and there's all these different types of number and integer. So learning something like JavaScript is much more straightforward for the newbie programmer. And tons of people already write JavaScript, right? There's so many JavaScript developers. So a lot of, Near is currently the marketing people at Near, their current thought is, if you can sell this to, if you can say like, if you write JavaScript, congrats, you're a smart contract author now, smart contract programmer. They're not the first to make this play, but they are also making this play. We'll see if it works for them. It hasn't worked for other people so far. So there's the, I don't know, like on the one hand, it has all these gotchas. It has the steep learning curve. But on the other hand, it has the highest satisfaction, right? Like 7 or 8 years in a row now on Stack Overflow's survey that gets sent out to developers. Rust developers are the most satisfied with their programming language. So it has incredibly high developer satisfaction. People who, like my impression of being a programmer in another ecosystem, both in JavaScript and in Ruby before that, was that people want to learn Rust. People are curious about Rust, and writing smart contracts is actually a good, like I found it to be a very good way to learn about writing Rust, because there are fewer, like in general, a smart contract is a very small, simple program, right? It's with 100 lines, a small like 100-line intro to computer science program is a currency, right? It's a fungible token because it turns out you just have to implement this handful of functions, and that is, because it's running in the context of a blockchain, that's a currency. So I found like once I had some once I had been looking at smart contracts for a while, going back and reading the first 4 chapters of the Rust book kind of gave me all of the context I needed to be able to write smart contracts, or at least to like modify smart contracts that I was helping with.
Yeah, I definitely agree with you. I think there's like this obsession around mainstream appeal and trying to market smart contract development to everyone. Anyone should be able to write a smart contract. Every JavaScript developer in the world, and this touches on like a bigger point of like what smart contracts are good for, and we're strictly like, I definitely think that kind of like financial systems or systems that are adjacent to financial systems are kind of like good candidates. And do I want, your average Joe JavaScript developer, writing my financial instruments, like the code that controls my financial instruments? I'm not sure that's the case. Like, I don't think that we need everyone to be writing smart contracts. And I do think that if you look at specific ecosystems, I think Rust is not the perfect programming language for smart contracts. It's probably the best we have right now. But I think that if you look at the Rust ecosystem, which is an ecosystem that is built on a foundation of safe programming, that's the type of programmers I want to be, writing my financial instruments, right? So I just think it makes sense. And this idea of let's have every JavaScript developer write smart contracts, that's I'm happy for others to pursue that, but I definitely don't see eye to eye with that.
I wonder too if there's a parallel or a metaphor here we can use from, so like Ruby on Rails. I wasn't writing Postgres functions or anything, right? Like I think of the smart contract as, or the smart contract platform. I think of the blockchain almost as analogous to the database in traditional apps. And like the database is its whole own complex like ecosystem knowledge area. There are database administrators, right? DBA, and like that's a whole career. You can make a whole career out of being a database expert. And so should smart contracts kind of be considered similar in that like it's its whole own like deep area of expertise, and integrating with smart contracts, or maybe even doing something that's more analogous to like creating new database tables and creating indexes on them, right? But like not the like stuff that a Ruby on Rails developer does with the database.
Yeah, I definitely think we're going in that direction. And OpenZeppelin is a great example in the Ethereum ecosystem. You know, no one actually writes their own ERC20 contract. No one actually writes their own proxy. You'd be considered crazy even trying to do these things. So yeah, I definitely agree with that. And I really like your analogy to databases, because blockchains are databases. And, you know, databases have been around for a while, and there's a lot of literature, and we've gotten really good at building databases. The irony, and this goes back to my point from before about how we keep reinventing the wheel, a lot of people building blockchains don't necessarily come from like the database world or the database state of mind. And so, you know, they find themselves making a lot of, a lot of the mistakes that kind of like were common in like early days. And I think that one example that, and I think we talked about this in the past, is if you look at the cross-chain contract calls in some networks like Near, for example, where they're asynchronous, there's like this whole universe of pain of like non-atomic interactions between smart contracts. And the world of databases, especially like financial databases, that would be considered horrific. Like the idea that you know, like a set of operations that are related are not atomic in their execution is hell on earth. And then you have you can write a trade engine that executes partial trades, right? Which is a big problem. You can and if you actually want to implement or make it look atomic, you actually need to implement the logic yourself. You need to implement rollback logic, and we can do better.
Yeah, that's one of the big trade-offs with Near, right? I talked about you can use STD. It's easier to use all your favorite Rust libraries, but then you also have to worry about, in order to make Near's sharding work, they had to make contracts asynchronous. So you have to, each block, a cross-contract call, that next call happens in the next block. So it's already by the time, and then that could call something else, which calls something else, which finally makes a call back to the original contract. But now that block is finalized, right? Like what's there is there, what's done is done. And so you've got to like figure out like, oh shit, like this thing didn't work. And now I've got to like figure out how to roll things back. And so that like atomicity, the atomic transactions are something that's pushed off to the contract authors rather than being something that's baked into the system. So it's like a huge trade-off that the Near team made. It's a conundrum.
It is. So we are we're approaching our time. Can you tell us a bit about what's around the corner, or what's ahead for you and AHA Labs?
Sure. Yeah. Our definitely like that idea of the Ruby on Rails for the open web, Ruby on Rails for the decentralized web. It's like still a lot of research left to me, right? There's a lot of questions about what that architecture actually looks like in practice. And even at this point, like since when I was working for Near, when I was paid by Near exclusively to work on their stuff, it would have made sense to build it like, oh yeah, you've got all this other stuff, but when you need smart contracts, use Near. But now that to me is an open question, right? Like, should we build this in a cross blockchain way where it's kind of, which smart contract platform do you want as the author of the app? Or is that a convention that we set for people? So do we just pick Near or Sorobon? Do we let the author pick? Or do we keep like exploring other options and also give people the choice of CosmWasm or Solana or maybe Ethereum? Or, right? It's like, once you have that in play, there's so much to keep up with in this world and so many options to explore. And at the same time, the other pieces of that stack are still also in play to me. I don't even know what the correct way to build a heavy front-end app is in 2023, right? Like, React seems to be what most people reach for, but is it the best way? Is it what's next? Is it what the experts in front-end would tell you should be using? Those are all open questions to me. And then that's all still assuming the web, and like maybe the future of apps should also be more cross-platform and be something that you can install. So like, yeah, I would say these are all the things that are in my head that I would like to explore more. And it's still kind of, for me, it's that question of like, what is the prime stack? What are the conventions around decentralized apps? For Aha Labs in general, there's also my co-founder, Willem, is much more curious about how WebAssembly is sort of change programming at a more fundamental level. So like anywhere WebAssembly is happening, he's more curious about that. So that gets into the future of web technologies and a bunch of different smart contract platforms that use WebAssembly, but also gaming platforms, and WebAssembly is starting to be all over the place now. So those are like the things that make us curious.
That's awesome. And I'm glad that people like you are working on this. I have some reservations with the concept of Ruby on Rails and how much we should adopt that for the world of blockchains. But I think that's probably,
by the end of my time using Ruby, I was like an anti-Rails Rubyist, right? So like, it's not that I think Rails was great or made all the right decisions, but I think having a place for most people to start is kind of the thing that I want, where it's like, here's like at least a starting point. And then, like I said, experts can disagree on like, you shouldn't do that thing. You should do this other thing, right? And like making it a like plug and play type architecture. But that all gets much more complex. So I guess, yeah. But I think we might be out of time for that conversation.
We are, yeah. Next time is on Ruby on Rails. Thank you so much for joining, Chad. This was great.
Yeah.
And have a great rest of your day.
You too.